All right, so what we're looking at now is dimensional analysis. That's the topic. Now, dimensional analysis simply means check your units. Okay, we're just going to be checking our units today and converting back and forth. Before we do that, though, let's look at the front side of this page just to quickly look at scientific notation so we're all on the same page here. Not literally, but figuratively. All right, let's look at number 2. It says, convert the following into scientific notation. O, 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 2, 3. Okay? Convert to scientific notation. So we're looking at number 2 on the front side. We're going to do this together. Yeah, we're going to go through a few of these together. And then I'm going to leave something for you guys tonight to work on. Tell me what we got.
2.3 times 10 to the negative fifth. Which one is it? Number 2 on the front side.
Okay, number 2 on the front side. Number 2.
Jack, that's not the front side.
Now, why would you say that it's negative? Explain that to us.
Instead of moving the decimal, yes, yeah, because you have to move the decimal back to get it back.
Yeah, because if you were to start in between the 2.3, you would move it over 1, 2, 3, 4, 5 to the left.
Okay. That's fine now. I know a lot of you heard like move the decimal, know which way, right? So it helps. It might be easier to think about it a different way. So let me go into one more example, one more detail here. This number here, to go from here to here, is it getting smaller or bigger?
Smaller.
Good. So if I look simply at this number right here and this number right here, it's going to get smaller. Whenever the number is getting smaller, it means you have to have a negative exponent. That's how I like to think about it. So sure, you definitely need to count the decimal spots. 1, 2, 3, 4, 5. There's where the 5 comes into play, right? The 2.3 and the 5. But to remember that it's negative, remember that you're going from here to here in your mind, and that number gets smaller, so this needs to be a negative exponent. Okay? Negative exponent.
Yeah, so you have to
Okay?
compare from answer, looking at the answer first.
Yeah, when I do it in my head, I sometimes compare it from the scientific form to the standard form. It sometimes helps me, you know? Instead of memorizing left and right and stuff. All right. What about number...
I just don't get number 4 because you wouldn't do the 0 afterwards, right? That wouldn't.
Oh, you want to see how that? Okay, because that, so 0.010. What would this one be? How many spots are you moving it?
Just 2, right?
Yeah, just 2. Okay, so it's going to be 1.0, I guess. The 0.0 doesn't really matter. We're moving it 2 spots. So this number from here to here gets smaller. So it's times 10 to the negative 2. Okay? Again, that was number 4.
Number 8.
Sure, number 8. How do I convert 4.50 into scientific notation?
4.50 times
Times 10?
10. Oh, wait, no. It's already in. It's already good.
Close, close. We're on the right track, Masha.
4.5.
Not first. You carry one.
0.
0. Because you want to say 1, right? Very good. You want to say 1. So think about it as times 10 of the 0. So this is really... Now, remember this exponent indicates how many spots you're moving the decimal? Well, did we move the decimal at all? Well, it's 0. And 10 to the 0 is 1. Remember, mathematically, we all know this. A to the 0 is 1. Any quantity of any real number to the 0 is always 1. All right, let's do one of the next section, maybe number 13. Let me get a hand for this, please. Let me get a hand. Give us some instructions on what to do here. Paul.
You move the decimal 3 places to the right
Very good. How come, Paul?
because it's 10 to the third.
And third is what? What kind of a number?
Positive
Good.
number.
We see this positive number. As Paul said, we're going to move it 3 spots to the right. So what do I get in standard form? What's it going to look like?
9,110
Where'd that 0 come from, Paul?
because you're moving it another spot.
Yeah, very good. If I move this 2 spots, I get 911. This is 2 spots to right here. But I got to go 1 more spot. So there needs to be a 0 placeholder right here. And think about it. Whenever you have a decimal, aren't there an infinite amount of zeros forever? If I had just 9.11, it's really 9.11, 0, forever. So there are zeros here. There's an infinite amount of them. But we only can go 1 more spot. So we're only going to use 1 of those zeros. Okay? If I had something like, I'm not going to do it, but number 11. Number 11 is a negative exponent. So what kind of an answer will I have? A decimal. Because number 11 is a negative exponent, thus it will get smaller. So it's a decimal. All right, flip over, please. Please leave the rest of these for later. Don't work on them now just because I want you to focus on the back. The back is much harder than what we just did. Let's all flip over.
Action.
So we're now on part 2 on the back. Let's take a look at number 1. Let's take a look at number 1. It asks us to convert from days into seconds. From days into seconds. So before we do the problem,
Seconds or a day.
somebody raising their hand, please tell me, what is actually going to happen here? Are we going to get a large quantity or a small quantity? Mom? Large. Why, Mom?
Because seconds is smaller than days.
Exactly. So there's going to be a lot of seconds, right? Think about it. Count how many seconds are in a day. Aren't there a lot of them? So it's going to get larger no matter what. Now, for this problem, we'll go back to our dimensional analysis idea that we started with before. We'll cancel units. So let's start with days. Tell me now, what is my goal? What do I want to get to? Seconds. Gary. No. Okay. Gary. Okay. And next. Sorry. So I want to get to seconds. Okay, I want to get to seconds. So I put seconds in my answer over here. That's an S. Smartboard is not agreeing again. Sorry. So I start in days, I want to get to seconds. So I need some sort of conversions here. Mom, give me one of them. The first thing I should do.
Into hours,
Okay, so what goes where?
20, hours on top,
Okay, and what's in bottom?
and then day on the bottom.
Explain to the class why, Molly. You put days in the bottom?
Because hours is the next thing, so you measure a day.
Good.
So,
And why are days in the bottom? Why are these flipped?
because the bigger,
What are you trying to do with this unit?
Cancel it out.
Very good. We are canceling days. We don't want days anymore. We want seconds eventually. So if days are to cancel, they got to be on top and below. What are the numbers, Molly?
24.
Good. Okay. Next. I'm currently in what? What units? Hours. I want hours though. What do I want? So what could I go to next? Before I get to seconds, what do I go to from hours? Minutes. Good. All right. So now I know I'm going to have minutes and hours. How many minutes are an hour? 60. My hours are on top. So where do they go? On the bottom. Cancel. Remember, top and bottom always cancel. Put minutes up top. We got 60 over 1. We need more room. Our next conversion factor.
Minutes to seconds.
Minutes to seconds. Good. Paul, tell me how do I actually do that?
You do, in the numerator, you get 60 seconds over 1 minute.
Why?
Because there are 60 seconds in a minute.
And why am I not the opposite?
And then, so you can cancel out the minutes.
Good. Very good. Cancel out the minutes. Now, let's take a look at this problem at this point. What do you notice? What's left on the bottom? Anything? Just ones. Do they matter? No. Dividing by 1 is like the same number. So all that's left is up top, really. So multiply the tops. So up top, we got 2.83 times 24 times 60 squared with units of seconds. Now, who has a calculator? Tell us what we got here. Multiply. 500. In scientific notation, negative fifth?
Positive.
Wait,
Okay,
what?
okay. Why is it positive and not negative?
But don't you only do it with like zeros?
Say again?
Don't you only do it like with zeros or numbers?
Well, I asked them to convert to scientific notation, so take a look, right? You start here, right? Where's the decimal? Right here?
Yeah.
1, 2, 3, 4, 5 spots.
So
And I
you
think,
wanna get it-
I remember this number is small over here, right? This is a small number, and it's becoming a much larger number going backwards, thus there's a positive there. Okay? Questions on that one? That's our easy problem to start with. Let's get to a tough one. Let's take a look. That was the other one, yeah. Let's take a look at number, God bless you. Number 8. Number 8. We did one of these similarly a little while ago. 19 milliliters, and we want to convert that to centiliters. So, what did I tell you earlier that might make sense? Go back to what?
You need to convert the milliliters to liters.
Good. Go back to your base unit. So, tell me what the first conversion is.
It would be,
Give me units first, and then we'll do numbers.
okay, it would be 19 on top, no, milliliters on top.
You're asking me or telling me?
Well, I know it's 10 to the negative third.
Okay, good.
Gabby? So,
Now, where's milliliters currently, everybody? So, I gotta get rid of it.
Please go on top.
On the bottom.
Yeah.
Focus, people, focus.
Liters would be on top, and then you do 10 to the negative third on top.
Why?
Because milliliters is already on the bottom. So you
Good. Remember, this M you see here, everybody see that M? That M means 10 to the negative third, milli. So I've got a 10 to the negative third on the bottom. I need to balance it, so put one up top.
Yeah.
Okay, again, remember, if you see the milli on the bottom, put the 10 to the negative third up top. If milli were up top, 10 to the negative third on the bottom. Now I'm in liters. Everybody see that? But what do I want to get to?
Centiliters.
Okay, somebody else now tell me. If I want to get rid of, I want to get rid of liters here. I want to get rid of the liters. Want to tell me what we're going to do here for this one?
Yeah, and put the 7 meters on top,
Good. And what's on the bottom?
meters,
Very good.
and
Centi means what again?
just a negative second.
Good. So where do I have to put that to balance it?
Bottom.
Very good. Well done. Again, remember there's a centi up top already, which is 10 to the negative 2. So I gotta balance this centi right here with this 10 to the negative 2, so that it's actually a value of 1. Remember, this quantity is really 1. That's equal to 1. This quantity here is really 1. That's what allows me to multiply. Because if I take a number like 5 and multiply by 1, it's still 5. I'm not changing the value ever. Okay? It's like when you find a common denominator for fractions. Remember how with fractions, if you had like 2/3 and you wanted to make it a 6 on the bottom, you would multiply by 2 over 2, and it would become 4 over 6, common denominator. This is a quantity of 1. It's the same thing we're doing here today. Okay? It's quantity of 1. Next. I need to simplify and make this look a little prettier, right? What do I got going on here?
You can turn centiliters, no, you do milliliters. 1 milliliter is 10 centiliters to the negative third.
Hold on one step, Paul.
Wait,
We've already converted our units. What's the step after converting units? That's what I'm asking you. What do we still have to do? Don't we have numbers everywhere? What should we do to those numbers? Okay, so up top we're going to have 19 times 10 to the negative third times 1, which doesn't matter, remember that, over 10 to the negative 2, and my units are going to be centiliters. Notice, cancel, 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 I'm left with centiliters. That's where the units here are centiliters. But that doesn't look nice, does it? Right? Come on, we don't want to leave an answer like that. What does that mean to us? So, Molly, what might our next step be here? What can we do? Okay.
could you switch around them?
I see what you're saying, Molly. You're saying combine these some fashion, right? It might make it easier to make all your exponents positive first by moving them. So remember, if I have a negative, very good. Very good. Good. Again, I know it is a little bit of an extra step, but it does help sometimes to have all positive exponents. It really does.
You don't
It
have
makes
to,
it easier.
you don't have to change the 19 then.
No, the 19 stays. Why does the 19 stay, guys?
Because,
It's positive.
Because its exponent is positive. What's its exponent? Isn't it really a 1?
yeah.
Is that the exponent there? So the 19 has a positive. Don't worry about it. Okay? Next, if I have two things with the same base and the exponents are different and I'm dividing, tell me what I'm going to do. Subtract them. So this is going to be 19 times 10 to the negative 1. Now, centiliters. And I want to write this in scientific notation. 1.9, good, because right away we know we're going to have to move this decimal over here. Okay? This is where it gets a little tricky. What's going to happen next?
So we're making a number smaller, right?
Correct?
So we want to make the exponent
Very good. So what's the next exponent though after 10 to the negative 1? If you go larger. 0. Which is just what? 1, really. Let me explain this. Take a number line, start at negative 1, okay? So, Jeff. Again, I get it. So what Jeff is saying is this. This number went from 19 to 1.9, which means it's getting smaller, right? So to compensate for that, this exponent here has to increase. Well, we moved the decimal one spot, so this has to increase by 1. But 1 above negative 1 is just 0. So this is going to be really times 10 to the 0 here. But 10 to the 0, as we said a minute ago, is just 1. So your final answer is 1.9 centiliters. Okay, 1.9 centiliters.
Oh, negative 1 is 0.
Now, if you get good enough at this stuff, if you really do and you want to do in your head, that's fine. Because personally, 19 milliliters, I would think of milliliters. Think about a ruler. When you have a ruler in front of you, let's say we look at the first 2 centimeters of a ruler. What are the centimeters broken up into, everybody? Millimeters, right? And there's 10 of them. That's the 5 mark, 6, 7, 8, 9. 5 mark, 6, 7, 8, 9. 1, 2, 3, 4. 1, 2, 3, 4. So there's all your millimeter tick marks. Didn't this start with 19 millimeters or milliliters? Not that it really matters right now. Is it 19 right here?
Yes.
Right? This is 10 millimeters. Here's another 9 millimeters in a sense. That's 19. Well, think about it. In centimeter terms, it's 1.9. And this was in liters, but it's the same thing really. So if you get to the point where you're able to do this in your head for a problem like this, you can. That's fine. Okay, but if you're struggling, or if it is not, maybe as clear, I would highly recommend that you continue to use dimensional analysis. Okay, let's do one more before we end. Number 10. This can be tough. So we're going 60 kilometers per hour to meters per second. All right. The first step I'm about to tell you is probably the most important step. How do I write 60 kilometers per hour when we're doing dimensional analysis with all these factors? How would I write? What should it look like?
6 times.
No, not scientific notation. I mean, like, how would I write it? Remember our last problem? In this last problem, we started with 19 milliliters. It looked like that. Now I have 1 unit there. But currently, I have 2 sets of units. So I'm asking, what should it look like? We still need the units of hour, which should be good. Believe it or not, I know it sounds very trivial, but if you mess up this part here in the beginning, your unit's going to be way off. This means you've traveled, not walked, that's really fast, but you've traveled 60 kilometers per hour. How many hours? Per 1 hour, right? That's when that comes into play. So tonight, because you're going to finish it tonight, see on number 12, number 11 at the bottom, it says MPH. What's MPH stand for? So when you write miles per hour tonight, you better write it like this. Miles per hour. Okay? And put your number up top with the miles. Just so you have an idea of it. So we start with 60 kilometers per hour. What's my goal? Meters per second. Okay? So clearly, I'm going to be changing how many sets of units? 2. Hours go to seconds. Kilometers go into meters. Fun fact or trivia question for you. Which one should I do first?
You should do it. Wait.
Kilometers to meters.
Distance? Okay.
No, you should.
How many people think we should do the distance first?
Because it's like much, it's easy to convert it.
Okay. How many think we should do the time first? For those that didn't raise their hand, what's your response? Out of curiosity. Good. It doesn't actually matter. That's the right answer. Hold on, Gary.
Actually, I would say 60 kilometers. I mean, that's kilometers is 1,000, which multiplied by 1,000, so it's like you guys say.
For simplicity reasons, one of them might be better to do first, but in reality, it doesn't matter. Now, Garrett, since you answered, here's a follow-up. Why does it matter? The answer is correct. It doesn't matter which one I convert first. Why is my next question? And this is mathematically the answer. doing when I convert? What operation am I performing? What is it, Molly? Multiplication. Isn't multiplication commutative?
Yes.
Does it matter the order? It makes no difference. 3 times 5, 5 times 3, they're both 15. So since I'm going to be multiplying by conversion factors, it doesn't matter which one I put first. Okay? That's the reasoning. Let's do it. So, with that said, I saw more hands for distance, so we'll do that first. Doesn't matter then. So, my first conversion factor is going to convert distance. Somebody tell me, I want to get rid of kilometers.
You put them kilometers on the bottom.
Well done.
And you put meters on the top, and then you
Good.
put 10 to the third on the top.
Very good. Why is it 10 to the third? Because 10 to the third means?
Kilometers.
Good. We see kilo on the bottom. Kilo on the bottom means 10 to the third. It's got to be balanced, so we put a 10 to the third up top. Good. Now, watch what I'm going to do. As you go along, you're welcome to cancel your units so you remember. Am I done with distance?
No.
Yes.
Oh, yes, you are.
I am. I am. Meter, I want to get to meter. I'm done with distance. Next, I want to get time, right? If I want to convert from time, I'm currently in what units? Hours. What do I want to get to? What's my goal?
Seconds.
So, be careful. Where are hours, everybody? Where are they right now?
On the bottom.
So where must hours be?
On the top.
On the top. Remember, it's no longer you're going to put them on the bottom this time. So for your next conversion, the minute you see hours on the bottom, please put them in the top. Okay? Next, what do we convert hours to first? Minutes. How many hours or minutes, units? What are the numbers here? 60 what?
Minutes an hour.
Good. So 60 on the bottom, 1 up top now. Remember, people, there are not 60 hours in a minute. There are 60 minutes in an hour. So you need to be very careful there. Suddenly we have numbers in the denominator, notice. Finally, the last conversion. What do you got? Well done. So I can see my units I'm left with. At the end, circle your units, please. Meter, right here. Second, right here. Look at the units we wanted. Meters per second. It makes sense. Okay, it's got to make sense. Final step. You want to make it look good, right? So up top, what do I have?
60 times 10 to
60 times 10
the third.
to the third. That's all I see. Very good. On the bottom, what do I have?
360.
Close.
Oh, yeah, that's
60 squared, let's just say for now.
Wait, because you
It's 3,600 by the way, Paul. That's why I said close. So, I'm going to write it as 60 squared. Why am I writing it as 60 squared, people? Because there's a what? Not to the third. Be careful. You're on the right track, though, with the idea of the exponent. What's on the top and the bottom? 60. So I can cancel, right? This is really 60 times 60, isn't it? So one of these 60s cancels. So during the problem, if it makes it easier for you, if you notice you have 60 and a 60, you can just cancel in the problem also. Keep that in mind. These are all factors, right? Factors can always cancel. So if you want to cancel during the problem to make it easier, you can. So you're left with 1,000 over 60. Again, this is 1,000 right here. This is 60 that you're left with. My units are meters per second. And I might want to actually divide. Drop a 0, right? Everybody see the 0 drop? You all know that rule?
Yeah.
Okay, if you have all zeros at the end, you can drop how many there are. So you got 100 over 6, 15.6, repeating, I think, something like that? 60, rather. It is repeating, right? Okay. All right? And again, is it worthwhile to put this in scientific notation, really? No, because it's a number like 16. When your problem has a bigger number, it makes it bigger. Finish up the worksheet, front and back. Okay? Finish it up front and back. Do we have class tomorrow?
I think so.
We'll double that tomorrow?
Oh, yeah.
Okay. Tomorrow, did I say this yet? What to bring in for that? Okay. Tomorrow, I did say. Oh, the cylinder. Remember I said cylinders?
Oh, yeah.
Okay, bring in cylindrical objects tomorrow. You're going to need one, I'll tell you now. Be prepared.
One in art.
Any cylindrical object, it's up to you. Not Eddie. Keep it PG rated. Have a good day, guys.